Regarding the plate, they are stripe of biomaterial containing holes that can accept screw pegs, which can be conventional or locking. The type is either is tension band. It is applied on the tension side to resist gapping. Bone strong in compression, so better to apply the plate on the tension side. Compression is by pre-bending the plate, side, concave side to the bone to prevent gapping on the opposite side, placing screw eccentrically in the combi hole to slide down slope of the axilla of the oblique fracture. To slide with compression can be screws which are oval or circular screws, better for simple fracture. Standard plate rely on friction between the plates and the bone. Broad DCP has advantages because there are multiplanar screws. LCDCP has advantage that periosteal blood flow is not compromised. Locking plate has advantage because the threaded screw holes are there to allow the screw to lock and act as a fixed angle plate. It acts as an internal external fixation, can be used for osteoporotic bones, can bridge a comminuted fracture, better pull-off strength of the whole construct, preserve blood supply, sits off the bone, it is expensive, and cold welding is possible. For the pull-out strength of the whole construct, it is important that the gap should be around 7 mm between the bone and the plate. Stability of the construct determined by the screw plate interface rather than the bone plate interface. Use thicker screws, increase core diameter and low pitch, as the stiffness of the construct it depends on the bending stiffness of the screw and not on the pull-out strength. Stability increases by bicortical locking screws, increase number of screws, screw divergence of screw less than 5 degrees, longer plate. A bridging mode provides relative stability, relative length of the and alignment, preserve blood supply of the fracture fragments, long working length, better for comminuted fractures, obeying the parent strain theory. Multiple fragments will distribute the strain and reduces the strain at each particle. So therefore, bridging plate will work in comminuted fractures while not in the transverse fractures. Secondary bone union, don't pull screws across bridge part of the fracture. Neutralizing plate is basically once you put a lag screw, you put a lesser neutralizing plate to avoid the torsional rotational forces. A buttress plate or anti-glide plate. A buttress plate is a plate which is resists shear forces during axial loading. Buttress is when you are applying to the intra-articular fracture, anti-glide when you are using for diaphyseal fractures. Working length is distance between two screws closer to the fracture, unsupported segment, 6 to 8 cartridges each fractures, site to neutralize torsional forces, rigidity or bending stiffness is proportional to the cube or third power of thickness of a rectangular structure. Regarding tension band principle, device that transform distraction tensile forces into compressive forces by translating the center of rotation of the fracture from the compression side to the tension side. So it transfers the center of rotation from compression side to the tension side. Need to neutralize rotational forces with a K-wire, implant plate or wire strong enough to withstand tension forces, need strong opposite cortex to bear compression load, intact buttress of the opposite cortex is important, fracture should not be comminuted, device K-wire and cerclage wire or plates. Olecranon can be used for tension band principle, patella, medial malleus, greater tuberosity of humerus, fifth metatarsal. Tension band can be used for small fracture that can't be fixed with other techniques. In patella, quadricep muscle and patellar tendon exert tensile forces on the anterior aspect Cerclage wire resists tensile forces and energy transferred to the posterior articular surface aspect as a compressive load.